So today we're talking about our parallelograms. We're back on our hierarchy. We're going to fill that out. And it's a nice, easy day because it's just one shape. Last time we did 4 different shapes on here. Today, only parallelograms, right? So it's going to be way less information. Let's start with the definition. What is the definition of a parallelogram? Two pairs, parallel sides. So you can pause the video if you need to write this down. Symmetry line-wise, let's see. Do you feel that, like right here, this would be a symmetry line of the parallelogram? Is everything on the left side exactly the same as everything on the right side? Why not? You know, and if I went like this away, do you feel that that is a symmetry line? Any of those symmetry lines? Nope. The fact of the matter is that a parallelogram does not have any symmetry lines. There is none. When it comes to the diagonals, we want to know if there's anything fancy about it. Remember, like the fancy things could be, they could be perpendicular to each other, they could bisect each other, and they could be equal. Those are the 3 fancy things, and one of those does happen. The diagonals of a parallelogram do bisect each other. They bisect each other. And remember, that means that they cut each other into 2 equal pieces. They bisect each other. So when you write this on your test, just by putting the word bisect isn't good enough. You have to say bisect each other. Here's what that's all about here. So on my little drawing here, I got a blue diagonal and I got a green diagonal. You see how the blue one totally cut the green one into 2 equal pieces. Thank you, tick marks. You see those, right? And then the green one totally cut the blue one into 2 equal pieces. Hey, talk with your neighbor real quick. Are the blue one and the green one the same length? Talk with your neighbor. Those are not the same length because we would have said equal here. All these guys do is bisect each other. So let's pretend the entire blue thing is 12 units long. Then would you believe this is 6 and 6? Are you with me on that? If that whole thing is 12 units. And what if the green one was 10 units long? Then wouldn't each one of these be 5 and 5? You see how they cut each other into 2 equal pieces? It's kind of weird. And then there's 3 properties of a parallelogram that we're going to have to remember. The cool thing is you know a lot of them already. Like, let me just give you this. If this side is 10, does anybody know how long this side of a parallelogram is supposed to be? 10. And if this side was 4, then shouldn't this side be 4? That is the fact that opposite sides are equal in a parallelogram. That is one property of parallelograms that I think we knew in the first place, that opposite sides have to be equal. Opposite sides have to be equal. Another thing is that opposite angles are equal in a parallelogram. Opposite angles are equal. So like if I numbered these angles 1, 2, 3, and 4, you know, opposite angles are like 1 and 3. You see that they're like a cross from each other. They're not consecutive with each other. So if this one is 100 degrees, y'all, then guess how much that one has to be? 100 degrees. The opposite angles have to be equal in that case, right? And then the third property is that any 2 consecutive angles are supplementary. Any 2 consecutive angles are supplementary. So back to my picture, if I had these 1, 2, 3, 4, again, any 2 consecutive angles, would you believe 1 and 2 are consecutive angles, right? They're right in a row. 2 and 3 are consecutive angles. 3 and 4 are consecutive angles. 4 and 1. I'm just going to put 100 degrees in here again. What should the measure of angle 2 be, since any 2 consecutive angles have to be supplementary? What should this one be? 80 degrees. And then how about this? These are consecutive angles, right? If this one's 80, how much has that one got to be? 100 degrees. We'll look at that. Boom. Aren't those supposed to be the same anyway, right? You know. And then how much has this one got to be? 80 degrees. So, boom, you know, those opposite angles are equal. Any 2 consecutive angles are supplementary. Do you see how parallelogram is connected to trapezoid? Like right above it up here, there is a trapezoid. Isn't the property under trapezoid that consecutive angles between parallel sides are supplementary? Check this out, dude. Are those sides parallel to each other in pink? Yes or no? Yep. Are those 2 sides parallel to each other in green? If you go around the clock, you're always going to be between parallel lines, right? So that's why any 2 consecutive angles are supplementary. Cool. That's pretty much it for our hierarchy. You want to keep it out so we can use it, you know, but let's go to the practice sheet. Here it is, dude. I want to tell you a secret. If you can get this down, you will know the bottom. because everything underneath here totally flows. And I'm going to just kind of do it now. I'm going to just work on like the diagonals. I'm going to show you something. Why don't we do this on our hierarchy? You're going to save your life. What is true about the diagonals of a kite, guys? What is true? They are. Why don't you please put a big P right here? Those diagonals are perpendicular. Let's go to parallelogram. What is true about the diagonals of a parallelogram? They bisect each other. And over here on isosceles trapezoid, what is true about the diagonals of an isosceles trapezoid? They are equal. PBE. You guys have known me long enough. I make up dumb little acronyms, weird little phrases for things. PBE. I made this up years ago. You can make up any phrase that you want, but I call it peanut butter every day, right? PBE. Peanut butter every day. If you're allergic to peanuts, I'm sorry, but it's like peanut butter every day is what I do. How does that help me? I can now go do all of the diagonals real quick because question, do these like marry together? Would you believe that the rhombus's parents is the kite and the parallelogram? Like one of them's mommy, one of them's daddy kind of thing. Those are the parents. So guess what's true about the diagonals of these guys? Do you think it should be perpendicular? Does one of its parents have that property? What do you think, yes or no? Yep, so these are definitely perpendicular. Do you think that they bisect each other? What do you think, yes or no? Yes. The question is, do you think that they're equal? Did any of the parents have any of that going on? That didn't work. So check it out. Let's go over to rectangle. Should a rectangle's diagonals bisect each other? What do you think? Is that one of the parents? Who are the rectangle's parents? Let's just kind of talk that out. The parallelogram and the isosceles trapezoid. So what do you think? Should this guy's diagonals bisect each other? Is that one of the parents' properties in that case? Should they be equal? What do you think? Totally happening. And then finally, when it comes to the square, could you tell me who the square's parents are? Who is the square's parents? The rhombus and the, and a lot of people get that because it's like, oh yeah, the rhombus has 4 equal sides and the rectangle has 4 right angles. If you put them together, shouldn't you get a square out of that in that case? So would you believe that the square's diagonals are perpendicular because one of its parents has that going on, right? It's got some perpendicular. What do you think? Should they bisect each other? Should the diagonals of the square bisect each other? Yeah, both of its parents have that going on, so it's like, that's cool, it's going to bisect each other. And what do you think? Should the diagonals be equal? Do any of the parents of that square have that going on? This is how a hierarchy works, dude. If you know the top of the hierarchy, the bottom is going to flow. I guarantee you, you know its definitions already, right? You'd be cool with the fact that you know those definitions. You just figured out the symmetry lines. We'll talk more about it next week. But all you've got to realize is where the symmetry lines are, and we'll talk about them in class. But if you can memorize the top half of this hierarchy, the bottom fills itself in if you get how it flows down. Are you kind of okay with that? So it's just going to get, what I feel, easier and easier and easier because everything is the same story all over again. So let's go do this. Bad thing. According to the way I snipped this out, it doesn't look like this is a parallelogram. What is the title of your worksheet, though? What is the title of it? Parallelogram. So we kind of have to cheat a little bit and go, okay, this is a parallelogram kind of thing, right? So they ask us to find each variable. Here's how I talk myself through. What did they give me? Sides, angles, or diagonals? What did they give me on problem 1? Sides. Look to your hierarchy and see if there's anything you know true about the sides. Of course, we know they're parallel, right? That's part of the definition. But property-wise, what do we know? Opposite sides are equal. So how do you feel about those guys right there? Shouldn't those be the same? What would you like to do algebraically to set up a scenario where I could solve for A? What do you want to do? 2A should be the same as 3A minus 5. Isn't that what that means? If opposite sides are equal, you set them equal to each other. So solve for A, please. And I don't care algebraically what your moves are, how you made your moves or anything like that. I believe instead of bringing that 2A over here, I'm just not a fan of leaving nothing on one side of an equal sign because you got to put a 0 in its spot, I just move the 3A over, in that way. So cool. How about this? What could we do to solve for B? Are these opposite sides in a parallelogram? Yes, no, maybe? So shouldn't 2b minus 1 equal b plus 3? I'll let you solve. Very basic algebra at the beginning here. So I'm going to subtract my b over and get one more b over here. There's a minus 1 there, equals 3. B equals 4. On your test, you'll have like an answer blank to put what a equals and what b equals and all that stuff. But for here, we'll just write it like so. Cool. Not too bad, right? On number 2, that is also a parallelogram. What did they give you? Sides, angles, or diagonals? Angles. Look to your hierarchy to see what is true about the angles. You know a couple things from the hierarchy. Here's what I'd like you to discuss. Who would you rather find first, x or y? It really doesn't matter, but who would you rather find first, x or y? Okay, let's find y. How much should y be? I'm down. We'll just put it in the picture. Could you justify it? If the math judge was like, y, what would you say? Here's my question. Would you say definition of parallelogram? Is that part of the definition, or is it a property? Property. Which one of the properties did you use? Opposite angles are equal, or congruent, however we're going to say it. We're going to have to do this in some proofs here. I think we got some, maybe not today, but next time there's some proofs. Okay, let's find x. What you could do is you could go this way, boom, 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 or you could go this way. Aren't these consecutive angles in that parallelogram? Look to your hierarchy of what is true about consecutive angles in a parallelogram. Do a little math punching in the calculator, see what you got. Supplementary. So since consecutive angles are supplementary, if this is 44, what's that, 136? Is that right? Cool with that? Pretty basic so far. Next, this is a parallelogram because that's what this worksheet is about. What is provided for you? Sides, angles, or diagonals? Those are the diagonals. I know they're kind of like, there's some lengths in there, but aren't those the diagonals? Look to your hierarchy and see what is true about the diagonals. Tell me, what's true about the diagonals? Bisect each other. So I'm going to go tick, tick, and then double tick, kind of so. What could I do right here? This 19 and this x minus 2. What could I do to set up an equation with these tick marks right here? What should I do? Yeah, shouldn't x minus 2 equal 19? And isn't that what those tick marks mean? So what does x got to equal? 21. Please solve for y with your neighbor. Pause the video, get that done. These dudes have to be equal to each other. So shouldn't y equal 25 in that case? Cool. Please give number 4 a shot. If you would pause the video, see if they gave you sides, angles, or diagonals, and set up some equations that you know would be true based off your hierarchy. So please pause the video, get that done. People, because those were opposite sides, you know, like I set them equal to each other, and I did my algebra, and I solved for A, B, and 2, and for B, B, and 7. If you weren't sure about that, come on in and ask for help. Cool. So what I want to do is just kind of skip these. I think we can handle it, right? You know, and let's work on to some more complicated issues in this. So are we okay with what we would do with these guys? So let's go to number 7. Draw this parallelogram with your geometer. Watching some of you all draw stuff, many of you are using the rhombus. We want to use the parallelogram. Which shape number is that? Number 10, right? 9 is the rhombus. We want to use shape 10, okay? Shape 10. So I drew my parallelograms here. I also drew the other one just to save a little time. It's going to be John. Mark him by definition. 2 pairs of parallel sides. Draw in any symmetry lines. Checking out the hierarchy. Does a parallelogram have any symmetry lines? Yep. So then we'll just write none on the inside, just to realize that we actually answered the question. There is none. We'll do the other guy now. We'll draw parallelogram Cena. Mark him by his definition, like we did before. So, boom, 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 boom. I don't care which one's got single arrows and which one's got doubles, but they got to have it. And then it says draw what's fancy about their diagonals. So, of course, we'll have to draw the diagonals in, doom and doom. And I will let you look to the hierarchy, see what is true about those diagonals, and mark anything fancy that we put. With the tick marks. Because these bisect each other, so the green one just cut that guy into 2 equal pieces. So those have to be marked the same. I don't care if they're single ticks or double ticks, right? They just got to be the same. But on the other one, you can't use single ticks again, because would you realize if you did that, that means the green one and the red one were the same length, right? One of them has to be a set of singles, the other one has to be a set of doubles. Cool. Nice. What's our next guy here? All right, this is where the algebra steps it up. What value of x and y make this quadrilateral a parallelogram? So let's just start with a bit of an easier one. What is provided for us? Sides, angles, or diagonals? These are angles. You can look through the hierarchy and see what's true. I'm going to color these just to kind of talk about them a little easier. Who do you want to mess with? Like, pick 2 of the 3 that you would feel pretty comfortable with. It's like, okay, I know what I could do with these 2 out of the 3 provided. The green and the pink, the green and the orange, or the orange and the pink. Who would you like to pick on? So we have decided to take the green one, which is 3y, and set it equal to that pink one, which is 42, because those are totally opposite angles in a parallelogram, or in a shape, and if they were the same, that would be a parallelogram. So we will just solve. Would you punch that in for me? What does 42 divided by 3 turn out to be? 14. So boom, I'm going to go to my answer blank and do that. That wasn't too bad. Okay, now how do we want to solve for x? The orange one definitely has to be involved up in the picture. I don't have this, right? You know, I don't have that. So I can't like just rock with this, but maybe you could find it if you wanted to, or just come up with a plan. Discuss with them. We've come to a class consensus that there is many ways to do it, but what we really liked was that we could figure this guy out by knowing these 2 dudes right here have to add up to be 180. Since this is 42, doesn't this one have to be 138? Are you okay with that? And how does that help? Because now what's true about these 2? These 2, everybody, has to be what? Equal to each other. They got to be the same. So you can say 138 equals 8x minus 6. That is not the only way to do it. If you did it a different way and got the same answer as me and showed your work, you'll be fine. You know. So solve for x, please. So add 6. That 144 equals 8x. Is that right? Then help me out. I didn't punch it in. What's 144 divided by 8? 18? Are we okay with that? That also was not the most complicated one in the world, you know, but it is a little step up from the front page, but still not the most complicated one in the world. You feel okay with that? Let's see about this. Okie dokie. What did they provide for me? Sides, angles, or diagonals? Sides. I think we're down that this dude right here should equal that dude. Are you cool with that? Let's set up that equation. Follow my lead. I'm going to give you some like strategies of how to organize this. I'm going to say that 3x minus 2y equals 26, all right? And that is a danger zone. What don't you like about that guy? It's true. What don't you like about him? It has x and a y with it. And here's what that's a clue for. I'm going to not beat around the bush. That's a clue that we need to set up a system of equations. Like when you have x's and y's going on, or more than one variable, I can't solve for x without there being a y in the answer, and I can't solve for y without there being an x. So I want to try to get another equation right like it on top of it to where I can maybe solve a system. And where will I get that other equation from? Right here. Shouldn't those 2 dudes also be the same? Right? So I'm going to go 4x plus y equals 42. And would you notice that when I wrote them, I lined my x's on top of each other, I lined my y's on top of each other, and what's really important is to make sure your equal signs are also on top of each other, and then your constants. And that's why we had solving systems a couple worksheets ago to refresh your memory. I want to try to add these together and get a variable to cancel out. You can choose whichever one you want. There is an easier choice in here, in my opinion. Who would you rather choose, the x's or the y's? I think the y's would be easier to cancel out, because if this is a minus 2y, what do you need this guy here to be so they add up to be nothing? A positive 2y. So what I'm going to do, I'd like you to show this also, is whatever you're multiplying somebody by, I am going to take that blue equation times 2, and then I'm just going to put him right underneath. Got to multiply everybody times 2 in that equation, so wouldn't that be an 8x plus a 2y equals, got to take 42 times 2, should be 84. And then do your brain a favor and strike this guy out. Don't black him out. Blacking him out is like this. Like, don't black him out. I still want to be able to see what's underneath there, but just strike him out. Say, I don't need to see you anymore. And now here's where I do my addition. I put this little guy. It's kind of like back in first and second grade when they made you do this. If they still make you do that, you're going to add them up, but I don't put that little plus here. I'm going to add them up and get a variable to disappear. So what's 3x plus 8x, my friends? 11x. And right here, this is why this is called solving a system by elimination. I have totally added those up, and don't the y's cancel each other out. Equals comes down, and I got to add my 26 and 84. That should be 110. Is that right? And that equation is awesome because there's no more y's. It only has one letter with it, just x's. So couldn't we totally solve for x? Please do so. What does x turn out to equal, baby? 10. There's half our answer right there. X turned out to be 10. I need to find y. Well, I have x now, so I could substitute him back into any of these equations. I have 3 equations to choose from. What I ask very kindly of you is to do this little move. Show me where you're substituting 10 back in so I can kind of see what you're doing by doing this. I'm going to put 10. First of all, help. Should 10 go in for x or should 10 go in for y? It's got to go in for x. So I'm going to just say, I'm going to put it right there. You know, you don't have to go there. You could have put 10 in for x in this blue equation. You could have put 10 in for x in this green equation. I'm going to go into that red equation. And you are smart enough in an advanced geometry class to skip a few steps. I'm going to do 10 in here. It's 3 times 10. What's 3 times 10? 30 minus 2y equals 26. But I love it if you show me where you put that 10 back in for, so when I'm going through your work, if you made a mistake, I can see what you did. And then just solve this guy for y. Solve this guy for y. So solving systems. If that was weird for you, I got a couple more coming up. If you still don't understand how to solve a system, come on in and see me. I would be happy to help you solve systems. But that was just one example from a while back. Let's try another one. Oh my goodness. These are angles. So it has been suggested that we set this 7y minus 2 and this 3x equal to each other because, remember, this is a parallelogram, and don't we have parallel lines? Is this true? Bing, bing. Those sides are parallel to each other. Yes or no? Yep, put it in your picture. Is this also true? Boom, boom. Boom, boom. Is that true? Okay, so the math judge is asking why you would want to do that. So let me grab a highlighter. I'm going to call these the red parallel lines right here. What kind of angles are those in relation to those red parallel lines? It's been a while. Remember, starts with an A. Alternate interior angles. Those arc marks, do they both touch the red parallel lines? Yes or no? And do they touch the same segment for a transversal? So don't parallel lines imply that alternate interior angles are congruent. Remember that guy from a long time ago? So, yep, we can set those guys equal to each other. So let's do it. 3x. I'm going to use a pen, not a highlighter. 3x equals 7y minus 2. Crap! That is true. And I'm going to tell you that that sucks. Why does that suck? Even though it's true, why does it suck? 2 variables. You know what that means? We're going to need to set up a system later, right, to solve. If you've got 2 variables in there, we're going to need a system. So I need a whole other equation with x's and y's with it. Talk to me, dude. What do you think about these guys right here? Are these also alternate interior angles? If I double arc mark those, are they on alternate sides of that blue segment right there? And do they both touch these green parallel lines right here? What do you think? Yes? Should those be the same? Yes. What I'm going to do is not underneath this. I'll show you why in a second. Not underneath this, to the side of it, I'm going to write like 4x plus 1 equals 9y. Because we have a parallelogram, both sets of sides are parallel, right? The alternate interior angles are going to have to be the same. Each one of those two equations we have written have x's and y's with them, but they're not written in the order like we want for a system. Like back here, didn't we go x's plus y's equals numbers, like in that order, so we can do a nice little elimination thing? So that's what I want to do here. I want to get it to look like this. X's plus y's equals some sort of numbers. Sorry about that. Some sort of numbers. So would you believe the x's and the y's are on the left side of the equal sign, and the numbers should be on the right side of the equal sign? Talk to me about this red equation. Is this 3x in the correct place? We want all the stuff with x's and y's on the left side and all the numbers on the right side. Is the 3x in the correct place? Is he on the left side of the equal sign? Here is the equal sign. Is the 3x on the left side of the equal sign? Yes. So I don't need to move him. Is the 7y on the correct side of the equal sign? Nope. So I need to move him. How do you move that 7y over to the other side? We're going to do the opposite. In this case, it would be subtract. So the 3x is still there, and you want him to come first. The minus 7y needs to come next. Here is my equal sign. Talk to me about that negative 2. Is that negative 2 on the correct side of the equal sign, right? He's over there. You want him on the right side. Is he over there? So he didn't need to move either. So I'm doing that. The only thing that I had to do was move that 7y over to the other side. Cool? Let's do that on this green guy right here. I want the x's and the y's to be on the left and the numbers to be on the right. Is this 4x on the correct side of the equal sign? Is he on the left side? Yes. Is this 1 on the correct side? Nope. Doesn't he need to move over there, right? And if you want to, since we are advanced, tell me about this 9y. Correct side or not correct side? Doesn't that need to move over there? So 4x was good. How will this 9y get over here? Minus 9y. There's your equal sign. And how will that plus 1 get over to the other side? Minus 1. These two equations are what I want. I'm now going to stack them on top of each other. I want to stack those on top of each other. And what I want to try to do is add them together and get some letter to disappear. Well, this sucks. But it's not an easy move. I could cancel the x's if I want. I could cancel the y's if I want. Here's how I choose. Which one of those has the smaller numbers involved? The x's are dealing with 3s and 4s, and the y's are dealing with 7s and 9s. Who has the smaller numbers involved? The x's. I want to deal with the x's. So who is the least common multiple between 3 and 4? If you wrote out all your multiples of 3, like 3, 6, 9, 12, 15, 18, 21, and all your multiples of 4, 4, 8, 12, 16, 20, who's the smallest number on both lists? 12s, right? We're going to try to turn these into 12s. But one of them has to be a positive 12, and one of them has to be a negative 12 for them to answer to cancel out. So what do you want to take the top guy times to turn him in? Let's turn him into a 12. What do you want to take the top guy times? It doesn't matter. One of them is going to be positive, one will be negative. Let's just kind of do the same thing. How about we call this a positive 4? So wouldn't this turn into a 12? Are you with me on that? Now I'm going to do a double down doubler. I'm going to go down below. And what would I have to take this bottom equation times? He can't turn out to be a 12. He has to be a negative 12. So what would you want? 3 or negative 3? It's got to be a negative 3. And why I called this a double down doubler is because I'm going to multiply both equations. So what I personally do is instead of going down below, I go off to the right. I don't care how you organize yourself. Just stay organized. But I'm going to go off to the right and distribute this 4 through. So I'm going to get me a 12x minus 28y equals negative 8. And then I'm going to do that down below. Minus 12x. Watch your signs. A negative times a negative is a positive. How do you feel about that move? Just multiplying. And the whole goal was to get these to be opposite numbers of each other so I can add them together and get them to cancel out. So I will do that. I will add these guys together. Those go away. And a negative 28y plus a positive 27 is negative 1y. And negative 8 plus 3 is how much, y'all? negative 5. This is close to what I want. I don't give a crap about what negative y equals. I want to know what y equals. So wouldn't you divide both sides by negative? What would y equal? 5. Boom. Put them in the answer blank. I have found y. Guess what I still need to find? X. You have 1, 2, 3, 4, 5, 6, 7, 8 different places where you could substitute that back in and find x. It really doesn't matter which one you want to go into. I'm just going to go into somebody that's close to me, right? You know, so like I'm just draw your little circle and show me where you're going. But could you please tell me what letter you're going to put a 5 in for? Are you going to put them in for an x? You're going to put them in for a y. You got to put them in for a y. So I'm going to just kind of keep it simple and go right there. I'm going to put that 5 in for a y. So wherever you want to go, I don't care. You can go back up here where the numbers were smaller. It's up to you. But 12x plus. Grab your calculator and take 27 times 5 if you need to. 27 times 5. It's 135. That's what I got. Equals 3. And then just solve for x. So negative 12x equals negative 132, right? And then if you would please help me so I don't have to bring my calculator back out. That's going to turn out to be positive, right, because it's a negative divided by a negative. What you got? Is that okay? 11? It's a negative divided by a negative. Yes? No? Double check. 132 divided by 12. Yeah, 11. Hey, man, that was not an easy one. If you need help with these, you ask, right? I will totally help you. And, of course, we got one thing left, the proof. How do we start? Right, the given. Hey, new symbol. Take a big old wild guess what that symbol means right there. Guess what that means? That is our symbol for parallelogram. All right, so step 1. They gave me parallelogram A, B, C, D. Don't go marking anything. You know, people are like, should we supposed to mark like the parallel sides and all this? We're only going to mark what we're going to use. We know a lot of stuff about parallelograms. What are we trying to prove? Is that these two triangles are congruent. Let's quickly refresh. I'll give you one. You finish the rest. There's 5 ways to prove triangle congruent. One of them is side, side, side. What's another way? Angle, side, angle. What's another one? Side, angle, side. Angle, angle, side. Who's the weird one? Starts with an H. Hypotenuse, leg. So let's think about it. What could we do? We have kind of started in class. There are so many ways to do this. Somebody suggested that they see a shared side between that, so we can totally do that. Segment DB is congruent to segment DB. It's been a long time since we've done it. What was that reason that you can have a shared side? You guys said it in here, but I'm talking to the video people. Starts with an R. Do you remember that reason? That's the reflexive property of congruence. You could totally do that if you wanted to. We have then discussed that we have a parallelogram. Shouldn't these opposite sides be the same? So step 3 is I'm going to say segment AB is congruent to segment BC. The hardest part for us is we're still very, very new at this, is what to write down. I'm going to ask you if this is what you should write down. Is the opposite sides being the same the definition of parallelogram? Yes or no? It is not. Isn't it one of the properties of the parallelogram? So here's how we'll write it down. We'll say this. What does that say right there? Parallelogram. Remember this guy? What does that say right there? Implies, right? That implies opposite sides. Do you want to say equal or congruent, since we're in this proof right here and we're using congruent signs all over the place? Congruent. Parallelograms imply opposite sides congruent. Let's look back to our picture. Do I have enough information to prove those two triangles congruent right now? What do you think? Yes or no? Nope. So we got to do some more. What else could we do? It has been suggested that these sides, I'm going to use 3 tick marks, should be the same. Why should they be the same? Parallelograms imply is it the same reason that we just wrote down? This will be the first time I've actually done this in class. Some of you have been doing it on your homework, and it doesn't hurt my feelings. Is it the same stinking reason that I just used? You can kill 2 birds with 1 stone by writing them in the same step if you wanted to. Segment AB is congruent to segment BC. That way you don't have to write that justification twice. You use a semicolon and stack them on top of each other. If you want to write them out as a full fourth step, do it. Here's my question now. Do you have enough information to prove those two triangles congruent? Cool. Which way? Side, side, side works. So triangle ABD is congruent to triangle CDB by side, side, side congruence theorem. In my opinion, I think that was the easiest way to do it. Just to show you something else, I'm going to just start completely over and ask you this. True or false? True or false? Is angle 1 congruent to angle 4? True or false? True. Why? Is it the definition of parallelogram? What would you say? Parallelogram implies what? Opposite angles congruent. Then you could have done this if you wanted to, but you got to get the parallel line. That's a lot of work. And then you could have done a shared side and done angle, angle, side. There's lots and lots and lots of ways to do it.